Hey there, class. Mr. Husky here. Hope you're having a good day so far. We're continuing with chapter 8, which is exponents and exponential growth and decay and scientific notation and exponential properties. So today's section is 8.2, which is zero and negative exponent properties. Our essential question is how do we simplify exponential expressions using the properties of exponents with zero and negative exponents? Okay? So these boxes are kind of confusing and hard to look at, so we're going to kind of just adjust this a little bit, make it a little bit easier to understand here. So what I'd like you to do, if you have a chance here, is take any number you want, and on a calculator, take it to the zero exponent. So like, for example, if you do, let's see here, if we do 243, any number, I picked a random number to the power of 0, tell me what you get when you plug that in there. Pause the video, see how you do. Hopefully you got the answer was 1. If you plugged in 243 to the power of 0, you got 1. What about pi? Try doing pi to the power of 0. You should also have gotten 1. Okay? What if we did, for example, if we did 14,000 x to the 100th, y to the pi, and then z to the 1.5, all to the 0 power. What do you think we're going to get when we plug something like that in there? Anything to the 0 power is going to equal 0. So what I want to write there is anything to the, anything to the 0 power is going to equal 1. No matter what it is, if it has anything to the 0 power, it's going to equal the number 1. That's all you need to know about that, okay? Now let's talk about negative exponents. Negative exponents. So for example, if we have, let's see here, if we had x to the negative 6, and we also had 1 over 5 to the negative third. Okay, if we had either of these. So the way this is going to work, negative exponents work, is that you're going to flip them vertically. If it's in the numerator, it moves to the denominator. If it's in the denominator, it moves to the numerator. Okay, so if we have x to the negative 6, is there a denominator for that or no? There's not. This is over 1. So what we're going to do is put this over 1. We're going to flip the x to the negative 6. If it's a negative exponent, it's going to flip from numerator to denominator in this case. And then we're going to make it positive. And once we move everything, so there's nothing left on top, we're going to have a 1 left over. 1 over, and then when we move it, we're going to have x to the 6 on the bottom, and the negative kind of goes away. Once you flip it vertically from numerator to denominator, or vice versa, denominator to numerator, they're going to flip, and you're going to get rid of the sign and make it positive. Okay? Similar thing down here, we have 1 over 5 to the negative third. And when we take a 5 to the negative third, we're going to move it from the denominator to the numerator. And it's going to become positive. So we're going to have 5 to the third, all over 1. Once you move everything, there's nothing left in the bottom. There's going to be a 1 left over. And then 5 to the third is going to equal 125 when you multiply that out. Okay? That's how you deal with negative exponents, is that they move, if it's, yeah, like I said, top goes to bottom, bottom goes to top, and then when you move it, it becomes a positive. All right, let's get to some actual examples here. So, we have zero exponent property. What's 8 to the 0 power? Anything to the 0 power equals what number? It equals 1. Same thing over here. We have negative 34 to the 0 power. It's also going to equal 1. They're going to both equal 1. All right, negative exponent property. We have 7 to the negative x. So in this case, we have a negative exponent. This is all in the numerator, so I'm going to put this over 1. We're going to move it to the bottom because it's a negative exponent. So we're going to have 1 over, and then it's going to become 7 to the negative x becomes 7 to the positive x. And that's going to be our answer. It's going to be this. 1 over 7 to the x. Okay. Similar thing over here. We have 1 over m to negative 6. We have a negative exponent in the denominator, so we're going to move it to the numerator. And it's going to become positive. So we're going to have m to the positive 6 over 1 if you want to put that. Or you could just put m to the 6. Sorry about that. Recording this at school. All right. One or more properties now. Let's get into some actual properties here. So I'd like you to, I'm going to just kind of go through all of these, but what I'd like you to do is pause the video and see if you can try them on your own first before I go through them. See how you do. All right, let's go through number 1 together now. We have 1, 6, all to the negative second. This is pow-pow here. Do we have any pow-pow happening? We do. We have this pow-pow. The negative 2 is going to apply to the 1 and to the 6. So we're going to have 1 to the negative second over 6 to the negative second. Anything to multiply straight across? No. Any negative exponents? Yes, we have actually multiple negative exponents here. We're going to move both of them in this case. So this is going to equal 6 to the positive 2 over 1 to the positive 2. And 6 to the positive 2, 6 squared is 36 over 1. So that's going to equal just 36. All right, see if you can try number 2 on your own. Give it a try. All right, we have 7 times 7 to the negative second power. This is actually 7 to the first power. So we could do pow here first, which I would probably, we could do pow. Let's do that first. We're going to have 7 to the first times 7 to the negative second, right? Now, the next thing we want to ask ourselves is there anything we can multiply straight across here? The answer is yes. We can multiply straight across here. When we multiply 7 to the 1 times 7 to the negative 2, we're going to add the exponents. So we have 1 minus 2, which equals what? 7 to the negative second. Negative first, that is, actually, sorry. And now we have 7 to the negative first. Now we have a negative exponent. Next step is to check if we have any negative exponents, which we do. So we're going to put this over 1 and move it to the denominator. So we're going to have 1 over 7 to the first power, or just 1 to the 7th. 1 over 7, that is. Okay. All right, number 3, we have 5 to the 4th times 5 to the negative 4th. Any pow happening here? No. Anything to multiply straight across? Yes, we have 5. Both of these are a base of 5, so we're going to multiply them. And when we multiply, do we add, multiply, or subtract the exponents? We're going to add the exponents. So we're going to have 4 plus negative 4, or 4 minus 4, which equals 5 to the what? 5 to the 0. And anything to the 0 power equals? It equals 1. All right. Number 4. We have negative 5 to the 0 times 1 over x to the negative second. Any pow happening here? No. Anything to multiply straight across? Not really. Any negative or 0 exponents here? We do. What is 5 to the 0 power going to be? It's going to be negative. We have a 1. So it's going to be negative 1. This negative exponent is going to move to the top here. So we're going to have negative 1 times 8 squared. And that's negative 1 times 64, which equals negative 64 is going to be our answer. All right, make sure you're pausing between each problem to see if you can try them on your own. See how you do. All right, next one, number 5. We have 7 times m to the negative second. So we have any pow happening here? No. Anything to multiply straight across? No. Do we have any negative or 0 exponents? We do. Now, my question for you, we're going to put this over 1. We're going to move the negative exponents here. But are we going to move just the m, or are we going to move the 7m to the bottom here? Now, this is actually very important, okay? Unless there's parentheses like this, the negative exponent is only going to apply to what it's directly touching. In this case, the negative is only applying to the m in this case. So we're not going to move the 7. The 7 is going to stay where it is. We're going to move the m to negative second to the bottom. But the 7 is going to stay on top here. So we're going to have 7 over m to the second power, basically, okay? All right, and that's our final answer for this one. All right, number 6, we have 1 over 5x to the third, y to the 6th. See how you do for this one. All right, any pow happening here? No. Anything to multiply straight across? No, these are all different bases here. We can't multiply them. Any negative or 0 exponents? Yes, we're actually going to move the x to the negative third to the top here. X to the negative third is going to go to the top, so we're going to have x to the positive third once we move it. And we're going to keep the 5y to the 6th on the bottom. That's going to be our answer. Can't zoom very well here. All right. Last couple examples. We have 3m to the negative second power here. All right. So we have any pow happening here? We do. We have the 3 to the negative second and m to the negative second. So we're going to have 3 to the negative second, m to the negative second. Anything to multiply straight across now? No. Any negative or 0 exponents? Yes, we have 2 negative exponents working with here. So we're going to move both the 3 to the negative second to the bottom and the m to the negative second to the bottom. So we're going to have 1 over 3 squared m squared. They become positive. And what's 3 squared going to be? It's going to be 9. So 9m squared, 1 over 9m squared. And there's our answer. Okay. All right, next one. We have the quantity of 8n to the negative fourth, all to the positive third power. Any pow happening here? Yes, we have the 8 to the third and then n to the negative fourth to the third. So we have 8 to the third, n to the what? Negative, is it negative 1 or negative 12? Hopefully you said negative 12 because we multiply when we do pow here. All right. Anything to multiply straight across? No. Any negative or zero exponents? Yes, we have the negative exponents. We're going to move this n to negative 12 to the bottom here. So we're going to have 8 to the third. 8 to the third is 5/12, so 5/12 is going to be on top, and then on the bottom we're going to have n to the positive 12. All right, this is a hard lesson, so make sure you're asking lots of questions, getting help, and you know, doing your best work here and taking notes and doing what you're supposed to, and we'll get through this together. But thank you for watching. Have a great day. We will talk soon.